Welcome. All right, so what I have here is cosine of beta times tan of beta plus 1 times sine of beta minus 1. Now, the first thing I want to do is, looking at this, is I see that, well, I can multiply the cosine of beta times tangent of beta. And remember, tangent of any term, tangent of x, is going to equal sine of x over cosine of x. So I know that's going to be very good because then my cosine is in the denominator, and I know it's going to divide out with my cosine over here. So I'm going to rewrite that just so you can see it now. So that will be sine of beta over cosine of beta plus 1 times sine of beta minus 1. So what you guys can see here is now that can be over 1. So now cosine of beta divided by cosine of beta is just going to be 1. So now I'm just left with sine of beta plus 1 times sine of beta minus 1. Well, when multiplying this, you can see we could apply FOIL, but we also notice this is a difference of two squares. So by multiplying this out, all I really need to do is multiply my first terms and my last terms. So I have sine squared of beta minus 1. Now we need to see, can I simplify that any further? And I look back and I see a sine squared, so I automatically go back to thinking of my Pythagorean identity. Sine squared plus cosine squared equals 1. Well, here in this case, I have cosine squared of x equals minus 1. Well, if I subtract the 1, if I solve for sine here, or not solve for sine, but if I solve for cosine, and what I have is I subtract cosine squared of x on both sides. So I have sine squared of x equals 1 minus cosine squared of x. Then I subtract the 1 on both sides, and I have sine squared of x minus 1 equals a negative cosine squared of x. So therefore, sine squared of beta minus 1 is going to be the same thing as a negative cosine squared of beta. And notice that it doesn't matter if I'm transferring from beta to x. I like using x because it's a lot easier and quicker than writing in beta, but you guys can see how the difference is that we're going to be working with that. So there you go, ladies and gentlemen. That is how you simplify that trigonometric expression. Thanks.